Imagine living in a world where a sore throat, a small cut, or a routine surgery could become a death sentence. Just 100 years ago, that wasn't science fiction. It was reality. Before antibiotics, bacterial infections killed millions of people every year. Today, a single pill can often stop those same infections. But have you ever wondered how antibiotics actually work? How can something so small defeat billions of harmful bacteria without destroying your own body? The answer lies in one of biology's most elegant battles, a microscopic war taking place inside us every day. Before we understand antibiotics, we first need to understand the enemy. Your body is home to trillions of microorganisms. Most of them are harmless, and many are actually beneficial. They help digest food, produce vitamins, and protect against harmful microbes. But some bacteria are dangerous. When these harmful bacteria enter your body through food, water, cuts, or the air you breathe, they multiply rapidly. As their numbers grow, they release toxins or directly damage tissues, leading to infections such as pneumonia, urinary tract infections, strep throat, tuberculosis, or bacterial meningitis. Fortunately, your immune system is built to fight these invaders. White blood cells patrol your bloodstream, recognize harmful bacteria, and launch attacks. In many cases, your immune system wins without any help, but sometimes bacteria multiply faster than your body's defenses can eliminate them. That's when antibiotics become one of medicine's most powerful allies. A common misconception is that antibiotics kill every germ. They don't. Antibiotics work only against bacteria. They do not treat viral infections such as the common cold, influenza, COVID-19, or most sore throats caused by viruses. This is one of the biggest misunderstandings in healthcare today. Taking antibiotics for a viral illness offers no benefit and can actually contribute to a growing global problem known as antibiotic resistance. So, how do antibiotics know what to attack? The secret is that bacteria are fundamentally different from human cells. Although bacteria are living organisms, they have structures and biological processes that our cells simply don't have. Scientists designed antibiotics to target these bacterial features while leaving human cells largely unharmed. This is called selective toxicity, and it's what makes antibiotics such remarkable medicines. Think of it like disabling only enemy vehicles, because they use a completely different type of engine. Different antibiotics use different strategies to defeat bacteria. One of the most famous examples is penicillin. Many bacteria are surrounded by a strong protective cell wall that acts like armor, keeping them intact under pressure. Penicillin blocks the enzymes bacteria use to build this wall. Without it, the bacteria become weak and eventually burst apart. Human cells don't have these cell walls, which is why penicillin can attack bacteria without damaging most of our own cells. Other antibiotics take completely different approaches. Some antibiotics enter bacterial cells and stop them from making proteins. Proteins are essential because bacteria need them to grow, repair themselves, and reproduce. Without proteins, bacterial cells cannot survive. Others interfere with bacterial DNA or RNA, preventing them from copying their genetic material. If bacteria can't replicate their DNA, they can't divide and spread throughout the body. Some antibiotics even disrupt the bacterial cell membrane, causing its contents to leak out until the bacterium dies. Although these medicines attack bacteria in different ways, they all share the same goal: stop the infection while giving your immune system the advantage it needs to finish the fight. Not all antibiotics actually kill bacteria. This surprises many people. Some antibiotics are bactericidal, meaning they directly destroy bacteria. Others are bacteriostatic, meaning they simply stop bacteria from growing and multiplying. When bacterial growth stops, your immune system can more easily eliminate the remaining microbes. Imagine trying to stop an invading army. One strategy is to eliminate the soldiers immediately. Another is to cut off their supplies so they can no longer fight. Both methods can ultimately lead to victory. This is also why doctors carefully choose different antibiotics for different infections. Not every antibiotic works against every type of bacteria. Bacteria come in many forms. Some have thick cell walls, while others have thinner outer membranes. Some naturally resist certain antibiotics because of their unique biology. Before prescribing treatment, doctors consider where the infection is located, which bacteria are most likely responsible, local resistance patterns, and sometimes laboratory cultures that identify the exact organism causing the illness. Choosing the right antibiotic is similar to choosing the right key for a specific lock. But what happens if bacteria adapt? This brings us to one of the greatest medical challenges of our time: antibiotic resistance. Bacteria reproduce incredibly quickly. During reproduction, random genetic mutations can occur. Occasionally, one mutation allows a bacterium to survive exposure to a particular antibiotic. While susceptible bacteria die, the resistant ones survive, multiply, and pass those protective genes to future generations. Some bacteria can even share resistance genes directly with other bacteria. Over time, antibiotics that once worked extremely well become less effective. This isn't because our bodies become resistant. It's the bacteria themselves that evolve. The misuse and overuse of antibiotics accelerate this process. Taking antibiotics when they're not needed, stopping treatment too early, using leftover antibiotics, or taking someone else's prescription all give bacteria more opportunities to develop resistance. Today, antibiotic-resistant infections affect millions of people worldwide every year, making some infections increasingly difficult to treat. Scientists continue developing new antibiotics, but bacteria are constantly evolving as well. It's a race that modern medicine cannot afford to lose. The good news is that every one of us can help slow antibiotic resistance. Only take antibiotics when prescribed by a qualified healthcare professional. Never pressure your doctor for antibiotics if they determine your illness is viral. Always complete the prescribed course unless your healthcare provider instructs otherwise. Never share antibiotics with others or save leftovers for future illnesses. Every time you take an antibiotic exactly as prescribed, you're benefiting from decades of scientific research, microbiology, and medical innovation. If you found this explanation helpful, let us know in the comments. Don't forget to like this video, subscribe to Curiomedix where curiosity meets science, and turn on notifications for more evidence-based healthcare content that makes complex medical science simple to understand.